In this lesson, we're going to take a look at adding fractions that have common denominators. And this is just a quick little review from way back in elementary school. If you have common denominators, like both the sevens are the same, what you want to do is go ahead and add the tops. So you rewrite the fraction to say that you've got sevenths, and specifically you've got 5 of them, because you had 3 sevenths, and you got 2 more. So in all, you have 5 sevenths. So you just take and add the top and rewrite the bottom. So we use this with algebraic rational expressions like these. So these are rational expressions, but they do have common denominators. And all we have to do is do the math with the top. If the bottoms are the same, you just write the bottom, 2r squared, and I subtract the top. So all I have to do is really 7 minus 11. And 7 minus 11 should give us negative 4 over my 2r squared. Now, if possible, you want to go ahead and simplify further by reducing the negative 4 and the 2, and that should give you a negative 2 on top over r squared. Now, as a side note, I don't believe that you'll be asked in the lab, but I'll just say it just to note it here. Back when we were doing rational expressions with multiplication and simplifying, we should have said that here r can't equal 0, because if I put a 0 in for r, it would make the denominator be 0, and that would be undefined. So I'm just throwing it out there. I won't mention it again in this lesson, but it is worth noting. So notice here these are also like terms. Even though they're separated by subtraction, they're still the same. So if they are like denominators, common denominators, you can just write the denominator m squared minus p squared and just combine the top. So whatever math it has in the middle, you just move it up to the top. And you really just want m plus 11. Now there's no simplifying that you can do with the top, but the bottom has a little bit of simplifying because it is difference of squares. So I could go ahead and write that and see if anything cancels further. This might be sufficient as an answer in the lab, but I just want to show you the next step. I should rewrite this as m plus p times m minus p. So that would make my best answer be m plus 11 divided by m plus p times m minus p. Okay? And finally, for the examples that I have with common denominators, you can see that even a trinomial could be a common denominator if they're all the same. So all you have to do is rewrite your trinomial that's on the bottom, which is x squared plus 2x minus 8, and then do the math with the top, which in this case is, you just put the plus sign up, and it's 4 plus x. Now we usually write x plus 4 instead of 4 plus x, so we want to go ahead and rearrange that to be x plus 4. Now I wouldn't recommend stopping here because you should be used to factoring completely, and notice that this on the bottom should probably be tried to factor, so I should do a magic x, put negative 8 on the top, put 2 on the bottom, and then work through my factors of 8, which would be positive 4 here and negative 2, to multiply to be negative 8 and add to be positive 2. And so I divide each of those by x, and it's going to factor to be x plus 4 times x minus 2. And if I rewrote the whole fraction properly, I would put x plus 4 over my x plus 4 times x minus 2. And hopefully you notice that right here, these will cancel, and so there will just be a 1 on top and an x minus 2 on the bottom. So I still have to do some simplifying, even though it seems to be simple addition at the beginning. So if you have common denominators, you add, and then you just go ahead and reduce the rest of the way. In the next lesson, we'll be checking out what it looks like to have denominators that are not like this example here. So we'll start off with that in the next lesson.